Welcome to this session on debugging and monitoring. So if we think about troubleshooting an application, our application code could have different types of errors that will occur during execution. Sometimes these errors are logic errors, where our code is wrong and doesn't do what we expect it to do. And other times there are data errors, where our code may be correct, but the data that we're using makes it invalid, like inserting a duplicate identifier into a database. So these are certain types of errors that are easy for us to find. There are also other types of problems that can occur, like performance problems, security problems, or connectivity issues that we need to be able to detect and fix so we can make sure our applications operate reliably. Now, to be able to do this, we will use troubleshooting, which is a method that we can use to find where these problems are so that we can fix them. And troubleshooting in general has a tendency to combine both debugging and monitoring, which we'll be looking at inside of this session. So let's start with debugging. What is debugging? It's the process of finding and resolving whatever types of errors and defects might be in some piece of code or software that we're looking at. Typically, debugging will allow us to suspend code execution at a given point, and those points are usually referred to as breakpoints. And when we're at a breakpoint, we can analyze the value of the different variables that are available at that particular point. So if we break at a potentially problematic code area, then we can begin stepping through the code and allowing each piece of code to execute individually so that we can analyze each statement and the variables that are available at that time. Once we find the bug, then we can attempt to change the application logic to eliminate the bug. Now, debugging in Service Studio is relatively easy because we can place breakpoints on both client and server actions. So here we can see a server action, an assign, and a client assign action, and we can go ahead and right-click on these and ask it to add a breakpoint. And then the little red dot will show up indicating that we have a breakpoint there. For those breakpoints to be active, we have to start the debugger. So in Service Studio, we need to tell it to start debugging, and in that way, Service Studio will start the code and attach the breakpoints to that code so that we'll be able to see what's going on. All of the current breakpoints are listed in the bottom area where the debugger tab is, and we can go ahead and manipulate the breakpoints there. We can remove them or temporarily disable them, both from the tab at the bottom or by actually going into the actions and doing the same type of thing. Now, once we've begun debugging, we want to control the flow. And at different times, we may wish to stop debugging. We may wish to suspend the current requests that we're working on or abort those requests. Or we may just want the request to continue until it runs into another breakpoint. If we like to keep more fine-grained control, we can also do a step over the code that we're currently working on, which will go to the next step, step into, which will go into the details of that step, or if we're in a lower level piece of code, we can step out of that code as well. Or we can ask it to go ahead and break on any error that it occurs. So this gives us a number of different ways to control the overall debugging experience. While we're controlling that experience, we wish to be able to see the variables and the values of what's occurring in our code. So when code execution is stopped, we can check the values of variables, and there are a number of different ways we can do that. We can look at all of the variables currently in use. We could just look at the current local variables that are executing in that scope of a piece of code. We could look at a widget, so some type of graphical widget's properties. We can look at site properties, or we can set variables up inside of a watch, which keeps all of the variables there together. And that may make it a little bit easier if we know exactly which variables are going to be causing problems or are related to one another. Now, to start debugging, inside of Service Studio, if we're in a particular module, then by default, the breakpoints of that module will stop execution when requests are made to this module directly. So if we were in a to-do application, it would stop on any of the to-do breakpoints because we're inside of this application and module. But if we want execution to stop when the code is being called from a different module, then that module has to be set as the entry module. So when we go to start debugging, there is this area on the left that says what is the entry module. So if we want to be able to maybe debug some piece of code, but we want to start in the to-do module, that may be that we're currently working in something like the to-do core, which may be a different module that holds the data of what we're working on. So in that particular case, to-do will be where the request starts, but we'll still be able to stop on the to-do core breakpoints. So this gives us a way of being able to get to certain breakpoints by running them from the consumer of that module instead of that module itself. Now when we do debugging from a mobile perspective, for mobile apps there are 3 different debugging options. We can either debug from the Android device or the iOS device, or we can actually debug from an emulator using Google Chrome. And when we do debugging, OutSystems Now can also be used on Android to be able to debug the mobile apps that are running on the device. So OutSystems Now won't be able to do that for us on the iOS side. Now, there are alternatives to doing debugging. The Google Chrome emulation allows us to do quick tests and see what's happening, but in that case the plugins are not available, so it doesn't do quite as good of a job as something like OutSystems Now or one of the actual on-device debugging. And if we want to do on-device debugging, we need to install the natively generated app, and we need to generate that app in debug mode. So once that's installed on the device, then we connect the device to a USB cable and then to our computer, and that will allow us to go ahead and step through the code while we're actually working inside of the device. And that can be very important because debugging certain types of the user experience, certain parts of that experience, like the offline part or being inside of a native plugin, these types of interactions are only possible inside of the device itself. They wouldn't be available inside of the emulator. To get more information about debugging in general, you can go to the OutSystems 10 and look inside of Troubleshooting Applications and looking at the Debugging Applications article. Now, if we look at exceptions, inside of code, there are times when something unexpectedly fails and an exception will be thrown. There needs to be some type of exception handler to go ahead and deal with those types of exceptions. There are general exception handlers, but there are also specific types of exception handlers that can be dedicated to different types of exceptions. Specifically, OutSystems can deal with database exceptions, security exceptions, communication exceptions, and then from there, we can create any type of custom user exception that we would like. When an exception is thrown, it will be moved to the handler that has the most specific way to handle that exception. If it can't find a handler in the current execution context, then it will go and bubble up to a higher level context or an outer context until it can find a matching handler. But this begins to lead to the question, what if there is no matching handler? Well, then we need a global exception handler. At the module level, we can set up a global exception handler to define how uncaught exceptions should be handled. So by default, the onException action handler, which is under the common UI flow and is usually part of one of the templates that we start with, it knows how to handle communication exceptions, security exceptions, and then it also has a way to handle all exceptions. So we can edit this onException action to handle the different types of exceptions we would like. So we can extend any of these to handle them in a more specific way, or we could even add our own custom user exceptions. Now when we begin trying to debug an exception, once the debugger stops at a particular point, then we can begin stepping over the different actions, the different nodes that are in any of our actions. In this particular case, if we have a database operation and we try to step over this database operation, but this fails due to an exception, then execution flow moves to the exception handler. So because of the problem inside of the database operation, it doesn't continue on to sending back feedback. It will go ahead and move to the database exception. When this type of exception occurs, to get more information about the error detail, we'll find that in the exception message for that particular exception handler. So here in use, we see that the database exception has its exception message, and there's a problem with key 0 was not updated. So that helps us understand a little bit more about the exception and what occurred to cause that type of problem. Now, inside of the exception handlers themselves, there are properties that can help us configure its overall behavior. Here, when we look at database exceptions, there is an abort transaction property. And this is basically allowing us to say whether or not we should roll back all of the database changes that have been made so far during this action. If this is set to no, then that means that all the previous writes to the database still get committed. But if abort transaction is set to yes, then it will go ahead and it will roll back all of the database interactions up to that point. Now this is only available on the server side because on the client side it's not going to worry about or respect the transactions in the same way. Now in both database exceptions and other types of exceptions, we also have this property called log error. So when different types of exceptions occur, should this error be logged by OutSystems to the logs? If this is set to no, then it won't be recorded inside of the platform logs, and if it's set to yes, then it will. Logs are always stored on the server, but if we're working in a mobile app and that app is currently offline, it will store it in local storage, and then it will send those logs back when the app gets back online, so that the server will eventually get the information about when and how that particular error occurred. Now that takes care of sort of debugging, but then what is monitoring, and how would that be different than some of the things we just talked about? Well, we just said that while we're doing certain types of exceptions, we can log the information that occurred in those exceptions. So OutSystems is recording lots of different events that occur in a series of distinct logs. These log events don't have to be just errors. They can also include different types of benign situations, like how long a database query took, how long a web services call took, and we can add things to these logs as we want to. So monitoring is the act of analyzing and correlating the information in these logs to try to determine why errors may have occurred or strange behaviors are occurring. And this can include, noticing problematic patterns and trying to figure out how we can use that information to change the code so it doesn't cause future errors or different types of problems. Now inside of OutSystems, monitoring can be accessed through Service Center. So when we're inside of Service Center, there is a monitoring tab at the top, and the different types of things that are monitored are errors, general audits are logged, screen accesses, integration calls, extension calls are all logged, timer execution and processes, as well as the overall health of the environment. All of this information is logged, and inside of Service Center, the monitoring gives us access to be able to view the information in those logs. So it gives us the ability to filter that information. And we can filter these reports by application, by time, by the message content itself. And if we wanted to be able to export this, to be able to look at it in an external way, we can export all of this information to an Excel spreadsheet. Now, while we're on the server, there are times where we will see a details link that will allow us to get to more extensive information about the logged event. So sometimes the high-level event is just the overall description, and we want to get into the details of the message or actually look at the stack trace to be able to learn more about where the error occurred, and then we can use that information to help us and go back and debug that part of the application to try to learn more about what's happening or what the values of the variables are at that time. So that's it for debugging and monitoring. Hopefully this will make it easier to troubleshoot your applications when problems occur.